Hello everyone and welcome to today's webinar on Made in India AI network operations that's built on practical intelligence. I'm Mansi Taneja from ET Telecom and I'll be your moderator for this session. Before we dive in, let me take a moment to set the context. Enterprise networks are becoming complex, driven by hybrid net architectures, multi-vendor environments, and distributed infrastructure. For enterprises, managing these fragmented systems is a growing challenge. This webinar will explore how AI-powered network operations are transforming this landscape and aims to shift the conversation from managing complexity to delivering seamless user experiences. It will also showcase how AI makes networks more agile, resilient, and scalable, completely tailored to India's unique enterprise demands. And to share deeper insights on this topic, I am pleased to welcome Mr. Ashutosh Datta, Associate Vice President, HFCL. Ashutosh brings a wealth of experience in the telecom industry and cutting edge technologies. Welcome, Ashutosh. We are honored to have you here. May I invite you to set the stage with your opening thoughts and then walk us through your presentation?
Thank you so much for that honor. And it's a pleasure to be talking here. Frankly speaking, I'm not a public speaker. Please pardon me if you find things that are not usual, but I would try to do justice to the audience that have. And thank you everyone for coming, sparing time today to have this conversation. I wanted to bring forward, in general, what the industry is doing towards adoption of AI in networks and network management, and also the direction that HFCL, being an Indian company, is setting towards the vision of the Viksit Bharat that our Prime Minister Modi has given. So we'll go through that, and I'll just share my screen. So yeah, I think AI is everywhere. No matter where you go, whom you are meeting, whom you're talking to, I think the AI wave has taken us all through a major shift that everybody is anticipating, right? And a lot of people look at AI as a machine that can answer all their questions. And majority of the people look at it that ChatGPT is AI. But in reality, the mathematics behind it, I think people from the sciences background to some extent can understand, but it is even hard for them because AI that we look at today is built on decades of mathematical engineering and research, right? Starting from Shannon to Heisenberg, right? All those concepts that we used to study in our school books and forget after the exams are actually taking shape, I mean, here. And it is interesting to see that stuff, very complicated stuff like entropy, is inherent part of the models that we use today. It is not evident because, and that is the beauty of the solution, that we look at things in a highly abstracted way, which makes it so popular that every from a kid to a grandfather, people are able to try their hands on it. And the success of AI inherently is because of this fact, right? So we have abstract out a lot of details, but for us as an engineering organization, and for all our companies like us, involving AI was thought in a very different way. We were looking not to bring the punchline AI into our systems, but we were looking to get something really effective out of it, right? And if you look at a bit of history of AI before I get into what we do and what direction we have set, the history of language models dates to 1966 when this first model ELIZA was created at MIT. However, if you see the gap from there till 2009, 8, 9 time frame, there was very little functional work done on this because for a model, and these models, what we saw in 1966 were very primitive, right? So they often were making predictions that had a low probability of becoming right, and there were a lot of conditions. Secondly, there was no hardware available to train them. Train any machines to be able to give more predictable responses. It was only with the advent of NVIDIA and its GPUs, especially the CUDA architecture, that people started realizing that we have a way forward developing models and solving real world problems in real time. Before that, we used to have supercomputers, but even those supercomputers or even the supercomputers of today, if you look at the architecture, are not capable to be able to do so much of parallel processing that is required for any model of a reasonable size. And I'm still not talking about a large language model of the like of GPTs, because that is yet another world. But from 2009 onwards, people started playing. There were neural networks being trained on it, and there were outcomes that gradually built upon it. 2018, when the GPT series, right, what we call the generative pre-trained transformer architecture, that came into being, which is the birth of ChatGPT, so to say. And from there onwards, I think there has been tremendous excitement in the industries, in the model sector itself, and in all verticals, if you look at it, because there was a sudden realization that now it is possible to solve problems much easily than it was in the past, right? So unsolvable problems can be solved, whether it is a problem related to networks or it is a problem related to health sciences or legal. So people started to look at this in different ways. And this was the time when we at HFCL also started realizing the need and necessity for bringing something into our system that would solve problems in the non-traditional way. Of course, we have been in this industry for a very long time and been building systems and products, but we always had limited means to solve those problems. So 2021 is when HFCL released their first network management system based on a model. I would not say it was a large language model, but it was what we call the SLM, right? The more customized, smaller version of a model that had interpretations for specific areas in which our management systems required support. And then, of course, we know 2022 ChatGPT was launched, and after that, I think every presentation, every conference must have this AI prefix. I think without that, people don't join it. And this is for a reason. It's not that just it's only a hype, because people have shown results which are making a drastic difference, whether it is, I mean, manufacturing, whether it is telecom. All sectors have been able to envision how they would be utilizing this architecture. Today, I think we will be covering how we have looked at language models in the in our problem space, which is basically creating, deploying, managing, and monitoring large-scale networks, wired and wireless. Now, people who are familiar in the networking domain, right? The bigger problem is there is too much of complexity, and every new version of software, every new technology that comes in, it brings more and more jargons with it, which for a typical network operator, which is our target audience, it is difficult for them to be able to understand any of that or figure out whether a particular problem that their customers are facing is because of what. Right? And as we move, for example, in the wireless space, we move from Wi-Fi 5 to 6 to 7, and then eventually we go to Wi-Fi 8 sometime. All this is becoming more and more, and at the same time more complex, right? So we are talking about high efficiency networks, which obviously is going to bring in more complex algorithms. And unless and until this is abstracted out, it becomes very difficult to be able to keep our customers, who are the network operators, in control of what they're deploying. The same is the story if we look at it in the language model of the AI space. There's a lot of terms that come to people who are actually studying it, or as amateurs or as professionals. Not all of it really is required for everyone to be known, but for organization like ours, where we had to derive value for our customers from the solution that we wanted to build without knowing at least a bit of it, it becomes very difficult, right? And that is why we started much earlier than the wave. When the AI wave or the Chat GPT wave came in, we were already deploying systems which were intelligent and by way of artificial intelligence. So intelligence, if I say, is of two types, right? One intelligence is where we talk about systemic intelligence, and which has been there in all software from day one, right? Any software, any logic that we build has some amount of intelligence for taking decisions. But the problem is it is event based, right? So if you have a certain condition, you take a path A. If you have some other condition, you take a path B, and so on and so forth. The software logic is not as simple as I said. Of course, it becomes far more complex. But the way the intelligence is implemented in our software before the adoption of any AI model was mainly systemic, right? And we look at it as algorithmic intelligence. With the advent of models like the one we have built, the system is capable of learning from whatever data is generated from our networks. And sometimes we also simulate to generate data to train the models, which we had to do initially because we did not have enough data. For just to put this in context, now that GPT-5 is being talked about, which is supposed to be the next big thing, as per estimates, the whole universe does not have enough data to be able to train a model of the capacity of GPT-5. So there are challenges which the industry is facing, and step by step we are solving. So when we started, we had a similar problem that we did not have enough data, and data which can be cleaned and fed into a model which would help it make better decisions, right? So our journey started from there, where we were building a data set, or in fact many data sets, to be able to train our model for it to help our customers initially make better decisions and eventually make decisions on behalf of our operators, right? Because as I said, it becomes, as your networks grow, the costs of any sort of maintenance on those networks. So if you look at a system, this is just a representation, of course, and imagine this person sitting here is one of our network operators, and we give them systems which have hundreds of controls, fine tuning required at every level. And even if it does something today, if you're talking about wireless as a technology, it is so dynamic in nature that even if something works well today, maybe 3 months down the line, the RF environment changes. There are more organizations coming on the floor above or below you, and there is a need for fine tuning. Now, this becomes, of course, given the conditions or the complexity of networks today, this is quite prohibitive, right? The configurations are complex and they are very tailored. That means in what works maybe for an Indian customer might just not work for somebody who's in Europe because of the nature of walls, the way they deploy the network, the overall enterprise or home setups, the kind of infrastructure or even furniture that you may have, right? So it has to be tailored and regularly monitored, right? The problems that occur in the field, we being remote, is has always been a challenge, and there's a lot of truck rolls that our network operators had to rely on to fix smaller problems which their customers are facing. So how do we solve these, right? That has been the thought process in generally all network organizations or equipment manufacturers. And I think the AI has given us a very good mechanism or a way forward to be able to solve these problems without the customer actually having to worry about it. The other big problem is the end user is not a technical person. What they understand is their network has to work. If they are on a call, their quality should be good. They should not be experiencing drops, or whatever transfer of information they are doing happens in a reasonable time. The solution that operators had to rely on till now is by way of having tech teams and support teams positioned maybe regionally or sometimes centrally. And whenever a customer has a problem, he has to pick up the phone and call that support guy and try to explain the problem that may be facing, which seems simple for us as engineers. But if you look at a grandmom sitting in Europe, probably a support guy can't even understand what she's telling. Forget the grandmom being able to figure out why she's having a certain situation. So it makes a simple problem more complex, and sometimes a very simple problem, the tech teams might have to go through very complicated flows because they have very limited visibility or information from those networks. So in this case, the support guy is thinking about complex things. Maybe the network's not deployed correctly, or some way in which this deployment has been done, which is not tested, or it's an actual bug in the software, whether it's a configuration mistake. But this is all left to guesswork. And then we try different things. Customers have to be on those support calls for very long, and this leads to frustration both at the customer end and the network operator end. To solve these problems, of course, whatever we could do in software, that has always been there, and we have been evolving and improving upon that. But with the advent of a model being part of our offering, there is immense amount of abstraction that we are able to bring to the customers, right? Where they really don't have to I'm sorry, they don't have to even raise a support ticket, because the knock teams of the operators, they would get alarms and notifications about problems that their customers may be facing. Now, with the model with an AI engine under the hood, which is continuously looking for information that is being generated from the network, it keeps analyzing and identifying and characterizing the kind of problems, right? It has the ability to make predictions about near future failures of networks. For example, if the channel quality of a wireless network is gradually degrading, they would be able to get this notification from the model and take corrective actions. Abstraction is one of the most important features which any complex network must have, because unless and until details are abstracted out, often operators and tech teams, they end up doing things which are probably not required, creating more pain for the users than they were initially in. Having this also required having a lot of people on the ground, visiting customer homes or offices, trying to recreate problems. And the nasty thing about problems is that when a support guy is there, the problem does not occur, right? And then this leads to more frustration, multiple visits, and a lot of dissatisfaction in general. What we are trying to build is basically get all this information in a continuous fashion into a model, and let the model analyze the bulk of the data that is being generated, and trying to predict problems as they occur or even before sometimes, right? So just removing the need for support calls, or at least minimizing them to start with, and giving a greater visibility to the operators, or the knock guys, to see and identify a problem. One big thing that happens, which is a very common phenomena that we see, that the end customers typically report something while the problem is something else. Now, it becomes very difficult for a guy on the phone to be able to distinguish whether the analysis or the report being given to him is incorrect, or actually there is a problem as being described. These systems help the technical teams of the operators to get a correct view of what's actually going wrong. So, if we look at network management and its history, we have looked through, I think 3 to 4 decades of systems which have been used to deploy, manage, and monitor large scale networks. Right, we started with element management systems which were based on SNMP, where it was a regular polling method that used to happen, and the system would continuously poll each device, get information from it, and do some processing. Mainly, the purpose of these systems were inventory management and some amount of statistics and reporting. Then we moved into the era of policy based network management systems, which were capable of doing a fully connected methods where the monitoring systems, the management systems were connected to the network elements, and they were able to push configuration, gather good amount of statistics, and event notifications. Eventually, they became more intelligent, where we were able to take some smart ways of doing it. And now that I think all the operators are expecting that the costs being going northwards, it is becoming more and more important that we solve this problem in a different way. And that's where we're looking at interactive and self-optimizing networks, which are mainly AI driven, that we are talking about today. So no matter what we say, how complex the networks we build, at the end of the day, if you talk to a network operator, he only wants one thing, that his customer is happy. Whether we do it ourselves, we spend weeks or days, of course, this is not going to make the customers happy. So the idea is abstraction and being able to generate more and more simplicity for the operators. That's where the next generation AI powered dashboards play a role. The data that is coming through from our models, and it's a continuous flow of data, is enormous, right? So not only the data that the system already maintains, but also on a day-to-day basis, if a particular network is deployed, we were able to synthesize that information through a model and represent it for for our operators, not the end customers, but the network operators, to have a view where probably they don't have to ask any questions to their customers, right? If we are looking at a dashboard like this, where a customer makes a call saying that in a on previous night I had this problem, where this would be already available to the support team, and they would be able to validate that yes, indeed the problem reported shows up. Second thing, it also helps them drill down as to what could be the possible reasons. When we talk about wireless networks, a lot of times we observe that customers do not realize whether their deployment is suboptimal in terms of the coverage area, if they are connecting through lower data rates because they're using some legacy devices, or because in enterprise, a lot of cases related to roaming, where the roaming is not working as expected because of whatever reasons, environmental reasons. But a dashboard like this is able to very clearly tell why a certain problem would occur, and support teams can take corrective actions or, in certain cases, make recommendations to solve this. If we look at this in a little more detail, when we look at end users experience, right, we have to characterize it based on the types of problems that typical networks extend, and classification of those problems to identify if it is a customer specific issue, is it a client specific issue, or are we talking about a trend in the deployment itself, right? Because we as a network provider, we have to look at the whole solution that we offer, not just one customer or one product. Sometimes the network operators are trying to solve the problems of one particular home user, and at other times they have an issue which is happening across an enterprise where across multiple floors of a building, we may have a situation. This, I think, we had a similar case with one of our large banking customers who had deployed our network um, across their multiple campuses in a tech park, right? So there were multiple buildings networked, and so many floors of that building being covered up with the network. Now, with deployments of that scale, if we don't look at higher level trends, right, and we look at only the lower level granularity, we might end up making a wrong analysis. And this is where language model has helped us to a great extent, where we get a bird's eye view and then we zoom into a particular site or a particular network element and then to a particular client. And at each level, the amount of detail that we are able to offer now makes it very easy. I would not say very easy, but relatively quite easy, identifying and fixing the right problem. One big issue, as I mentioned earlier, also is that a lot of times there is a lot of trial and error, and this trial and error, I'm sure no customer likes. So we are trying to avoid that by doing the right analysis, and the current architecture that we're following has been helping us to a great extent to do a correct analysis of the problem before we make any recommendation. So in this case, this is a trend of what types of issues a particular client connection has experienced over time. So this also tells us that what are the areas where the network needs improvement, and we make recommendations accordingly. This is another more detailed view of the same thing, where we are, without the need to ask any questions to the customer, we get an opportunity to see the reasons for any failures. For example, the clients had instances of not being able to connect, and the unfortunate part with equipment manufacturers like us is most of the times we get the beating even for the misdoings of the station or the client vendors, right? Because people have a lot of faith in their handhelds or their computers, and they always believe that it must be either the network provider or the network equipment that's going wrong. So these situations help us to also make recommendations if we are able to identify that a certain type of problem may not be because of a bad network, but it could be because a client is not behaving the way it is expected to behave. Then we go one step beyond uh, to see how users are experiencing each of the different applications, because in today's world people are using WhatsApp, people are using Teams for their calls, and a lot of different applications which all behave differently. It's not the requirement, the bandwidth requirement, the TCP UDP spread, and a lot of factors vary so much that unless and until we take that into account, it would be difficult to give an end-to-end good experience for our customers. And then this becomes very important, where we are able to characterize the experience application by application. And then be able to see what was the time window where the user was impacted and what were the possible reasons. In certain cases, like here we show, right, the client switching into power save mode, which is obviously not realized by a user, but it leads to bad experience. So we are trying to characterize problems at the device level and also at the application level. This again, without having a model analyzing all the data that flows through a network, or at least the management frames, it would be very difficult to make an output or a characterization like this. So I wanted to change gears slightly here, and of course, I've been talking a bit about how networks and network operators have been leveraging AI. But we've also wanted to emphasize on the fact, as I mentioned, HFCL being a proud Indian company, which has been contributing in all verticals, whether it is telecom or defense or other areas. It is interesting to see how the AI story is molding in the Indian context. And to people who are following the activities, India has already set up an initiative which is called the AI Kosh, which is a platform for collaboration. And we are also exploring how we can contribute into this space where users would be able to contribute data sets which are tailored in the context of India. They would be able to build and upload models. So this is like a community where once you are a member of that community, you leverage the work done by others, and you also get to contribute to the projects that are being done as a part of the India AI initiative. We are very excited, and we're looking to see how HFCL as an organization would play a role to be able to contribute to this, because we have to solve problems in the Indian context. Of course, so far it looks like ChatGPT is the ultimate solution and can solve all problems, but we also have to understand the the dangers and the risks of using third party data sets, third party models, and third party infrastructure. In it With the advent of AI, I think, as all of us are must be seeing on our social media and the print media, that making use of models that are global in nature comes with its own risks, and sometimes they may not be tuned for the Indian context. It in networking context, if I think about it, it would be like our deployments, our density of users are quite different from maybe other parts of the world, and hence it is very important that our models are trained and fine-tuned using data sets from the Indian context. Now, this applies not only for networks, but for all fields, whether it is governance, whether it is education, whether it is healthcare. This has to be adopted with the right data set, which is relevant for the Indian context. And that is why there is so much of impetus from the government to participate in this initiative. So I just wanted to bring this forward for our listeners who have not seen it. I would, I mean, invite you to join the movement and also contribute towards it. So we have a more India-centric models and data sets in future. And of course, I mean, if you look at it from the business angle, there is a lot of opportunity. I mean, the estimates say that more than 100,000 startups, new startups expected in this space alone in next 3 to 5 years. So with that, also it becomes all the more important that we start looking at it, start contributing, and start building solutions that would improve the way we do any of the things in the world in the Indian context today. Now, if we look at how networks or network management is going to evolve right from here, we have already set our foot onto the journey towards using artificial intelligence to be able to detect anomalies in the network, make predictive corrections to the network. But to make this more formalized, I think there's a lot of work that is happening as I speak in terms of ease of use. Even today, an operator who uses our interfaces has to go through dashboards and pages, right? We are moving towards a more interactive way of network creation, whether it is deployment of networks, whether it is management or maintenance, right? So in a more interactive way. Then we are trying to make reporting less boring. Of course, rather than generating tons and tons of CSV files. We want to generate reports which actually tell the story, and anything that is related to inventory or logistics is probably handled separately, because that remains still remains tabular in nature. We are incorporating a lot of periodic self tests. So why does a customer need to actually experience a bad behavior before it gets fixed? So we are trying to be proactive in terms of doing self tests and mitigating problems as reported by those systems, right? And the self healing part, as I mentioned, becomes ever more interesting, because no user wants to see a problem. They want a network that works for weeks and months together without the need for they to be putting any attention to it. We are generating topologies which are more interactive in nature, where you would be able to build a network like a block like a block game, right? So where we put things together and deploy a network, and the configurations would get generated. There's a lot of MCP related, which is the new protocol that comes along with AI, where it is trying to standardize the interfaces, right? So today, we look at a model as one solution that is going to solve all the problems on planet Earth. In reality, in the enterprise and the commercial space, if you look at it, the model that is being adopted is that we have various smaller blocks of intelligence that are talking to each other, and they are having some standard interfaces, right? So this MCP architecture is another interesting area that is coming up and is very effective in building larger networks and large scale network operations. So you have to watch out for this, the work that we are doing and other vendors would be doing in this space. And eventually, I think the buzzword agentic behavior, where network management becomes fully automatic, right? Or autonomous, so to say. Very little need for network operators to deploy teams to be able to monitor a network, and the agents specializing in specific areas would control the network, do any required upgrades, do any configuration updates as they are required, without large teams monitoring and conducting those activities. When we look at the deployment that as HFCL we are doing, right, we are looking at the whole ecosystem and the solution that we deploy. Of course, for our engineering teams, they look at smaller chunks in terms of the equipment, how it behaves. But as an organization, it is very important for us to see how the solution scales up and how it is a frictionless network that we can offer to our customers, right? From the setup to monitoring to periodic maintenance to updates, and then getting insights and recommendations based on what's happening in the network, right? So that gives a bird's eye view, a full picture in terms of in network functions, in terms of what things might go wrong. And here, our AI model is playing a very significant role. Our infrastructure is also inherently designed to leverage the intelligence that is offered through the model. It is not that we have regular statistics being fed into the model, but it is filtered information. I mean, what we call structured data sets, right, are being generated and goes into the model, and there we build intelligence. So that makes us slightly ahead of a lot of competition, and solve problems which our customers are looking forward to. I think that's pretty much I had, Mansi. Questions, anything, I'll be happy to take.
Yeah, sure, sure. Perfect. That was a wonderful and quite an elaborate presentation. Captured the evolution of network management as well. So I have a few questions. You talked about why AI is critical for the modern network. So what are the biggest challenges that Indian enterprises face today? If you can talk about that as well.
I think one of the major problems when we deploy networks in India. So I've worked with a lot of companies deploying networks in North America, Europe, right? The cost of that network and the cost of managing that network, right, in the Indian context is very, very sensitive, right? We have to deliver that at a very price competitive point, and that is what makes this kind of solutions more effective, because every visit and every defect that goes through a triage process adds significant cost, and sometimes it crosses the margins of the product itself, right? When operators are deploying network equipment, the margins are so low, and since as Indian manufacturers, we also have to compete with the Chinese counterparts. There's a lot of product. It becomes extremely difficult to sustain any business if we have to do any sort of a manual work towards resolving problems in the field.
Right, right. So, can you also share some examples of how AI is being used for diagnostics and predictive maintenance in real world enterprise networks?
Yeah. So as I said, networks are very are crazy stuff, right? I mean, normally what for other stuff, what you do is you set up once and it works till the time it works, and then you have to replace it. The problem with networks is that they are affected by so many different factors, right? People add on more equipment, and the one that you had existing starts to misbehave, right? Or in case of wired networks, there's a problem of having loops in the network, right? So that kind of they are nasty problems. I mean, normally for operators who are deploying and networks, it is very difficult to find that unless and until there is intelligence built to be looking at the entire deployment rather than looking at individual pieces, right? And that's where I think this is a game changer.
Okay. So we have many questions from the live audience. So I'll have shortlisted some.
Mhm.
So one of the questions says, could you share what's your biggest win on how AI has helped with your network deployment so far?
I think the biggest win is getting that visibility, right? Without, see, the thing, I strongly believe that problems are only difficult because they are not seen. If you see a problem and it is available to you whenever you actually want to see it, it is far more easier. So I think visibility is one most important thing that this brings to the table.
Okay. Then another one says, which all tools do you use or recommend to use for AI enablement of network operations?
So again, as the industry evolves, I would want to admit that there are no tools available today that are off-the-shelf products that can be leveraged directly. Of course, during our development, we use a lot of AI tools for that purpose, but per se, there is no off-the-shelf model available that can be directly employed, and that is where a lot of effort goes in, right? To be able to tailor a system that understands networks and that also specific deployments, right? So I don't think I would be able to give a name here. Hopefully, in the days to come, with more MCP platforms building up, we may have something like that.
Sure. Then also, does the current AI model of HFCL only give suggestions or it can take immediate actions as well?
So the we have capability of self-healing. The model has capability of self-healing, but we are going slightly slow on it because we do not want to overstep, right? In terms of, for example, the impact of that again might be serious for our users. For example, one thing that we do is in case there is a need, we adjust the transmit powers of our radios, right, up and down. In case a particular frequency is becoming noisy, we give them capability to switch. But there is a lot beyond this that we want to do. But we are a little cautious and slow in deploying such solutions. But that is going to happen for sure.
Okay. Another one is a little technical, even I couldn't understand this. Is asking this new AI powered NMS, it's applicable for L0 to L3 domain because we are facing mainly issue for RCA in short span of time. Probably you can
Yeah.
respond to it better.
So the kind of visibility that we are building is from layer 2 to layer 7, right? So a lot of layer 2 infrastructure that we deploy, of course, most of the times we fix problems there and detect and mitigate issues there. There is visibility at the IP layer, there is visibility at the transport layer, and of course the application like I was showing. So the answer is yes.
Okay, okay. And what's the current maturity in terms of network monitoring using AI? How do you manage costs considering that this requires continuous data feed?
Right. So, good question. Uh, Cost is a factor, but we are building solutions in a way that the advanced capabilities would be licensed. So, there is some amount of monetization that we expect. And I forgot what was the first part of the question. Sorry.
How do you manage costs considering that this requires continuous data feed?
Yeah, so actually, no, because the models that we have deployed today are also sort of pre-trained models. Like the way we look at ChatGPT, right? They're pre-trained and then deployed. They're not being continuously trained. Of course, there is a reinforcement and feedback and all that, but that does not add so much to the cost.
Okay, okay. And another one asks, what is the right placement of AI models in a network? Are SDN controllers, which already have an abstraction of the network, the right points, or are external AI systems better suited?
I think, as I mentioned, right, the problem is we have to look at it more holistically rather than an SDN controller being the point of view. And that is why I think I would see this as the latter, where you have a model which is over and above your deployment. It's not limited to the controller itself.
Okay. So there are too many questions, so probably we'll take one more.
Okay.
Given that the proposed AI model in India is India centric, how does HFCL intend to support its international customers in developing countries?
Well, I think it is made in India for the world. So I'm sorry if I felt at any point that this is only works in India. And we are going to eventually train our models, and we have been doing that also. In the Indian context, I wanted to emphasize because there is a huge push, and we are doing things which are India centric. But at the same time, the solutions that we are building are for the world.
Great, great. So, lastly, we just come to the end of the session. If you can give your closing remarks on the roadmap for AI in enterprise network management over the next maybe 3 to 5 years.
Yes. So I think this is a very interesting phase. And I mean, for our generation of people, if I look at it, right, we have been very fortunate. We started from a point where we did not have the telephone, right? And then we came into an era where we had internet. And then we entered into an era of smartphones, right? So these are actually as important changes in the technological space as would be probably discovery of electricity, right? And then now with this AI revolution that we are experiencing, there is tremendous amount of change that we are anticipating, and all of everyone is anticipating, whether it is networking or other verticals in general. In networks, since we are talking about extremely large networks, right? And it becomes, I don't think we have found any other way in which these problems can be solved so effectively with minimal touch. So it's a very exciting time. I think in the next 3 to 5 years, we should see that a lot of the work that we do or the lot of struggle of our customers, right? Probably, if I want to give a context, right, there was an era when there used to be power outages, and okay, the fan stops working. And for people who are as old as me, I'm trying to age myself here, but and now I don't think the next generation, my kids do not know what is a power failure, right? So they think the power is always there, whether it is through a UPS mechanism or whatever it may be, right? But their TV sets never go off. I think networks would also see an era of that, where networks would be, people will take it for granted that networks always work. And we are moving in that direction and putting a lot of effort to make that happen.
Okay, okay. Perfect, perfect. Thank you so much for this insightful session. Just to mention here, we'll answer all the unaddressed questions after this session separately over email. And the video of the session will also be made available on ET Telecom in the coming days. Thank you everyone for joining in. Thank you, Ashutosh.
Thank you. It was a pleasure. And thank you, everyone. I see a good amount of participation. So appreciate your presence. Thank you.